Welcome back one more time. Welcome back. Here we are, Unit 14, last unit of the semester. Saving, I guess, the best for last, deserts. Putting a lot of what we learned together to kind of figure out deserts, why they are the way they are. It does have a little bit to deal with not only geology, but also meteorology and climatology, weather and climate. So we'll explore a little bit of that. But, obviously this is hitting close to home because this is where we live. All right, let's jump into this, shall we? Deserts. Strictly defined, a desert is defined as an arid land that receives less than 25 centimeters of precipitation in a year. That's 10 inches. And that's on average over a long period of time. Sometimes areas get more than 10 inches, sometimes much less than 10 inches, but this is average overall. So you'll see why that this number becomes interesting. So that's really what defines a desert. On average, it's an arid, dry area that gets less than 10 inches of precipitation in a year. Now, precipitation isn't just rain. Precipitation is water falling from the sky. Snow, hail, add it all up. Excuse me, you add it all up. All right. In deserts, specifically rainfall that does occur, is typically intense downpours during a brief rainy season. I don't know if that kind of sounds familiar. Let's see. Short, intense downpours during a short rainy season. Man, that kind of sounds like here. Interesting. In the desert, water erosion is common in most deserts. That's what moves most material around. It's also what causes, in some way, shape, or form, most weathering. Remember, weathering is the breaking down. Erosion is movement. But you can get frost wedging. You can get in deserts. You can get exfoliation. You can get root wedging. You can get a number of those different physical weathering attributes, but water is actually what's responsible for moving most of the material around the desert, even though there's only a little bit of it. And approximately 25% of the entire world's total land area, so of all the dry areas, all the land areas on Earth, 25% of that is covered with deserts. So there's a lot of deserts out there. I want to take just a quick kind of moment to talk about the second bullet point. Rainfall that does occur in deserts, typically intense downpours during a brief rainy season. Does that sound familiar? I hope it does, because that really describes our monsoon. All right, during monsoon, which here in the desert southwest of the United States occurs July, August, September, during those few months, a little bit before, a little bit less, depending on what's going on that year. But that's kind of where we get the bulk of our rainfall, and it's called the North American monsoon. And if it wasn't for that, we really wouldn't get much. We would be very well below that 10 inches of rain average per year. Again, more on that in just a second. I'll show you a chart. But so the term monsoon. So this is what sets me off every time. Monsoon, the word refers to a seasonal change in the direction of prevailing or strongest winds of a region. So monsoon basically is defined as a change in weather patterns. The word monsoon is nothing to do with rain. Rain is rain, okay? Rain is rain. A rainstorm is a rainstorm. A thunderstorm is a thunderstorm. Rain is rain. The monsoon is just describing what's happening climatologically to this area. Weather patterns are shifting. Again, I'll show you a diagram here in a second. So during our North American monsoon, because there's monsoons all over the globe, all right, different monsoons everywhere. Are they associated with rain? Yes, but that's not what the word monsoon means. So the North American monsoon is a pattern of a pronounced increase in thunderstorms and rainfall over large areas of the southwestern U.S., as well as northwestern Mexico, typically occurring somewhere between July and September. So July, August, September. Again, a rainstorm is not a monsoon. It's just called rain. The monsoon is just the broad term for the shifting of weather patterns. It's referring to the season of a shifting weather patterns. It's not referring to rain. Yes, we get a lot of rain, at least the bulk of our rain during monsoon. But again, monsoon is just referring to the season where the weather patterns are changing. The wind and weather patterns are changing. But again, the North American monsoon is the primary water source for most desert ecosystems in the region. All right, so here's kind of what happens. All right, here's kind of what happens in summary. Where we are on the globe in North America, weather patterns, wind patterns, typically move from west to east. So if it's raining in California, a day later it might be raining in Arizona, a day later it might be raining in Texas, it might be raining in Florida. It moves from west to east, typically. However, around July, the climate patterns tend to change as things start to heat up in the northern hemisphere, north of the equator. So you get this high pressure system kind of moving northward, and it causes the air to start to circulate. For the most part in the U.S., you're still getting weather going from west to east. Right? You're still getting that west to east, but because of this high pressure system, it's causing this clockwise flow moving up. And so what's happening, the wind patterns are now circulating. So when they're coming over Arizona, they're circulating over the Pacific Ocean, over the Gulf of California. They're coming over this moisture-rich area, this warm water, and this warm water is evaporating into the air. And as it's moving over Arizona, it's dumping that moisture in the form of precipitation, rain. So it's creating this, it's shifting this conveyor belt to pick up more water to dump onto Arizona. Here, again, any moisture that would be picked up is dumped in California. It has to go up and over mountains. There's a number of things that happen. We don't get that moisture. But again, during that July, August, September, this high pressure system kind of moves into the area, shifts wind directions. So that's the change in weather patterns. It's a shift in wind directions to where the wind overall, the weather for the most part on average is coming from the southwest instead of just from the west. As that weather pattern, as that air moves over the ocean or over the Gulf of California, picks up that moisture, dumps it on Arizona. That's how we get the monsoon. So again, instead of from west to east, we're getting this circular movement of air, a change in weather patterns, a change in wind patterns. The monsoon is referring to the season where this occurs. So just to show you some rainfalls for Maricopa, it's a city south of Phoenix. I picked it just outside of the big city because sometimes big cities have weird effect on weather. So this is just south of us in the desert, about 20, 30 miles or so. But you can see, so this is the average since 2007, and this is the current month up through so far what we have in November when this was being made, because this is from last year's data because it's not yet December when this is made. And then it shows you as far as the current month versus the average, whether it's less or more than. What I really want to point out, again, that July, August, September, so you can see that these averages are typically the highest. So on average, we usually get the most rainfall, July, August, and September, due to monsoon, the shifting of weather patterns, bringing more rain. Rain is called rain. But what is very interesting this past year is that if you look, so July a little bit more than normal, August so much more rain than average, over 4 inches more rain than average. Same thing in September, almost 3 inches more than average. So during this year's monsoon, it brought a lot of rain, much more rain. So in fact, the average 12-month rainfall since 2007 is about 9.6 inches. So again, 10 inches or less, desert environment. But the rainfall for the last 12 months is 15 inches. So technically, for this past year, it's more than what's kind of the definition of desert. But again, that's average overall. That's average overall. So we're 5.69 inches above average from what we typically are, which is very, very rare. But one rainy season, one good monsoon, one wet year doesn't detract from the fact that we're still in a desert. So in any case, I just wanted to throw that out there, only because it's one of my pet peeves. People, oh, there's a monsoon outside. No, rain is rain. The monsoon is just referring to this few-month period where we have a changing of weather patterns. You can bet there'll be some sort of quiz or test questions based on that, just because it makes me so angry. But in any case, this is all kind of a side note. So getting back to deserts. there are 5 types of deserts. Now we're going to pause here. When we come back, we'll talk about those types of deserts, because how each desert forms, it could be a little bit different, or a combination of factors. And it has to deal with topography, the terrain, locations, latitude, weather patterns. There's a number of things that go into creating deserts. So that's what we'll explore when we come back. See you in a second.